Welcome to Introduction to Engineering Design. This is Module 4.1c, Mathematical Modeling. You can find this up on the Canvas website under Module 4.1. Tab would be Resources, and then Activity 4.1c, Mathematical Modeling. So in this exercise, you're going to take your finished cube and you take it over to the scale and you're going to weigh it. To weigh it, you will weigh the individual pieces that comprise the cube and record the number of wooden cubes within that piece. I've done this in Table 1. I've recreated Table 1 and go to question number 2, and they ask you to graph your points. So what I've done is I've worked a little bit ahead here, but I've put my independent variable, which is the number of cubes, along the x-axis. I've taken and put in my dependent variable, which is the mass of the corresponding cubes, along my y-axis. And then I've gone ahead and plotted my data points. And you can see they're fairly close together. I ask you to answer a couple of questions here. And the first question is, do you expect this data to be linear? So what they're asking here is, if I added more cubes, would it weigh more, and would that weight go up in a relationship that is linear, or if I took cubes away? You can reason through that, but the natural response would be yes. If I took away cubes and I had like a 4-cube piece, it would weigh less than a 5-cube piece. That weight difference would be 1 cube difference. It does ask you a question in preparation to sketch a best line of fit trend along your data is, what would you expect the point, the y crossing point, which is where x equals to 0 or 0 cubes, what would you expect the mass of 0 cubes to be? Now, if you reason through that and you think for a moment, we say, well, obviously, if I had no cubes, I would have no mass. And that is true in our graph, is that it is approximately 0. It may not be perfectly 0 because your model may not fit it perfectly. Question 3c really walks you through and says, what would you expect the mass of a single wooden cube to be? Now, this is a fairly easy answer to reason through, so let's go through this real quick. There's 2 ways we can really easily do that. I could take the mass of a piece with 6 cubes and subtract the mass of a piece with 5 cubes. That would give me the mass of a single cube. Alternatively, what I could take is the mass total and divide that by the number of cubes. Would give you approximately the same answer. Somewhere around, for me, 4.5 grams, give or take a little bit. What it now asks you to do is to go back and sketch your best line of fit graph. So what I've done is I've gone back in here and I've sketched that graph. My slope of this graph is approximately 4.5. My y crossing is approximately 0. So I'll highlight those in blue. There's my crossing point. And here's my slope. It is the rise over the run. So in this instance, here is my rise. Here's my run. 1 cube goes up about 4.5 grams. Which leads you into the equation for the best line of fit. Now, knowing that this is a linear equation, we use the format y equals to mx plus b. And we know that b equals to 0 in this instance. So now we have y equals to 4.5x. The next question really asks you to put it into a function notation of m of n. In other words, the mass total based upon n cubes. And in this instance, all that you do is you substitute m of n for y, and you substitute for x the letter n. So m of n equals 4.5n. We do this so now we can basically deduce some answers, and we say that if m of n equals to 4.5n, then what is m with 2 pieces? That equals 4.5 times 2, which equals to 9 grams. And I should put grams as my unit of measure on each one of these. Conversely, if I know that I have a puzzle piece that weighs 31.5 grams, I know that that equals to 4.5 times n pieces. I can divide that out and find that the number of pieces equals to 31.5 divided by 4.5. Now realize you're going to have to round this to the nearest puzzle piece, because you can't have fractional puzzle pieces. And you ask yourself, well, why would that be inaccurate? Well, it could be several factors. Maybe not all your puzzle pieces are exactly the same. Maybe they're not all exactly the same density. Or perhaps you've got glue added into the puzzle that you're not accounting for. So that's the first exercise. The next up is to work in Excel, and we'll show that in the next video. Thanks for watching.